how do you define a data engineer? And I guess like how is that different than a software engineer for those that are maybe less intimately familiar with this world?
We define a data engineer as somebody who manages the data life cycle as it pertains to the role as a data engineer, right? While embracing the undercurrents of security, orchestration, data management, architecture, software engineering, and so forth.
Do you think that data engineers are not always given as much credit or respect within an organization as maybe other forms of engineering?
I think that's definitely been historically the case for sure. But I would actually extend that to data in general. Data is typically misunderstood.
Yeah. Do you think the data lake, as historically we know it, is just going to go away? Hey folks, it's Sean from Software Huddle, and boy, do I have a great one today because Joe Reis is on the show. Joe is the co-author of The Fundamentals of Data Engineering, probably the best and most comprehensive book on data engineering you could think to read. One of the things I really liked about the book is that it's really focused on fundamentals, which, hence the name. But it's not about specific technologies, but more the core principles that are widely applicable to any data stack. And beyond the book, we talk about the culture of data engineering, relationship with data science, the downside of chasing bleeding edge technology, and approaches to data modeling. Joe's got lots to say, lots of opinions, and is super knowledgeable. So even if data engineering, data science isn't your thing, I think you're still going to really enjoy listening to the interview. All right, last thing before I get you over to the show, Alex and I will be in Miami in April at the Shift Developer Conference, speaking and also doing interviews. If you're in the area, you should come on by, see some great talks, say hi to us. You can learn more about the conference at shift.infobip.com/US. And as always, feel free to reach out to Alex or myself on LinkedIn or X if you want to connect or share feedback about the show. All right, let's head over to my interview with Joe Reis. Joe, welcome to Software Huddle.
Hey, what's going on?
Not too much. As I was mentioning, I'm here recording, not my usual spot today. I'm recording from my day job's office, so don't have my new normal backdrop. Got this rather boring backdrop, but hopefully the sound, the office crowd doesn't come in till much later in the day, and it doesn't get too loud in here.
Okay, perfect. Sounds good for now.
Yeah. Anyway, I'm excited to talk to you. I've listened to a lot of hours of your podcast. I know you're not going to hold back. You're going to bring the heat, which I like. So I thought to start off, we could talk a bit about your journey to where you are today. I know you studied math in university. And how did you kind of go from there to machine learning, data science, data engineering to where you are now?
I mean, back then, I would say it's a pretty natural progression career-wise. Back when I was studying math, there weren't a lot of, career options available. Data wasn't the cool thing either. So, I think that the path, this is in the late 90s, early 2000s, your path with a math degree was teach, go work for the government, become an actuary. You could probably go be a bartender. I was actually a DJ at clubs, so that's how I made my money. Then I got a job actually as an analyst, but more doing data science-y type work. So, a lot of predictive work, a lot of optimization type work as well. So that was, I guess, a good application of my degree. But fast forward to, the 2010s, and that's when machine learning, I think, was taking off. And I think I started getting interested for real in it back in 2009, I think it was. It was like, I got to probably transition into this because that's when GPUs were starting to become available to the public for machine learning purposes. And I think the cloud was also starting to facilitate, machine learning. You gotta remember, computers back then were pretty crappy. So it's like you needed all the horsepower you could get. So yeah, I think we were even planning on using like an Xbox back then for machine learning purposes. But yeah, anyway, that's how I got into it. But yeah, I haven't looked back since.
And that was a self-taught journey at that point in terms of learning.
Yeah, self-taught. I mean, there weren't a lot of resources out there at the time. I mean, I think popular packages might have been like Weka or something like that back in the day. If you remember that one? Yeah. But it was just, that kind of got me into data engineering because I was working at a machine learning startup. We were doing automated machine learning. This is in the early 2010s. And, back then there wasn't a playbook for, I guess, whatever you call ML ops now, right? You have to kind of roll your own model hosting and all this stuff. And I came up with like automated feature engineering system way back in the day. And that wasn't really a rule book for any of that. So you just kind of had to make it up as you went along. But got to do what you got to do.
Right. Yeah, so I read your book recently, The Fundamentals of Data Engineering.
Condolences and thank you.
Well, I had a couple observations. So, first thing, I've interviewed, a number of people who've written books, and I'm not going to name names or anything, but let's just say not all business books are created equal. There's a large number of business books that are essentially like a 1,500 word blog post stretched into 140 pages of filler. And I would say your book is absolutely not this. It's basically a pretty meaty textbook. And I was actually reading it a few weeks ago on a Saturday night after my wife and I got the kids down. And my wife came into the living room and she saw me reading a textbook on the couch. And she's like, "Are you reading a textbook? Are you some kind of sociopath?" And the other thing, there's, I think, a lot of like tactic based books in our, in the space of data engineering, Spark for data engineers, Hadoop or Databricks for dummies or something like that. But your book is essentially, for the most part, technology agnostic. So why did you think it was important to sort of focus on fundamentals and start there?
I mean, there really wasn't any coverage of the fundamentals of data engineering back when Matt Housley and I decided to write the book. As you point out, there's no shortage of blog posts. There's no shortage of books really on data engineering on technology X, Y, or Z, or various cloud platforms. And those are great books, but up to that point, I don't think anyone had really taken the time to describe data engineering from first principles. And so that was actually the hard part of this book, was if you kind of peel back the field, like what is it exactly? And so that was the task. Interestingly enough, our acquisitions editor at O'Reilly, she told us not to do this book because she said it was going to be really hard for two first-time authors to try and define an entire field from the ground up. But I don't know. We told her we're kind of dumb, kind of crazy. So why not? Then she eventually came around to, I think, our way of the world. And, but I can't say it was easy, when you try and define something from first principles and you don't want to have the crutch of a technology, I would say it's not easy.
Yeah. I mean, you have to kind of take a step back at each time that you're describing sort of these things. It's like, if you think about a particular technology, it's like, well, what does that technology actually enable people to do? And then how do you sort of define that as a larger thing and where it fits into this, world that we call data engineering?
Exactly. And the crux is definitely understanding what's not going to change as quickly in a field that changes very quickly, right? So, and we distilled that down to a few things. It's like, and I don't see any situation where you're not going to obtain data from some sort of a source system. There's no situation where you're probably not going to have some storage mechanism for that data, ingestion patterns and queries, transformation modeling, and then serving it. I think all those are fairly rugged. They'll be around for a bit. And then all the undercurrents, I think, are what supports it all. So, but it's an interesting thought experiment. I don't know that I would change anything on it. So probably add a couple things, but that's about it. But,
Well, you can come up with a new version in a few years.
Matt and I are thinking already about what we'd add in the new version. I think orchestration probably is going to be a standalone chapter, but I'm not going to give away too much yet because I haven't formulated it. But you start nitpicking things about your book, and after it's written, and the idea was for it to be relevant at least 5 years from now, and I think it will be.
Yeah, I mean, if you look at like sort of classic first principles books, from like Knuth's books, for example, on the fundamentals or the art of programming, like those. He made up a programming language to describe these things. That's like, so that you're not even locked into the technology of like the programming language and sort of the, languages fall in and out of popularity. He basically, I'm just going to ignore that and essentially make up my own language to kind of describe these different things. And those started in, 40 years ago, and they're still as fundamental as they are today. So I think that the sort of first principles approach doesn't if you have that, you create these kind of classic works that people can go back to 10, 20 years down the road.
Oh, for sure. Yeah. All these books were great. Then also the Martin Kleppmann's Designing Data Intensive Applications. I thought that was, definitely the de facto data engineering book at the time, even though it was actually written for software engineers and not data people, which I thought was interesting. But, that was the one that everyone gravitated towards. And it's one of the greatest books of all time, I think. At the same time, if you look at how data engineering changed from the time Martin published that book in 2016, 2017 to today, or when we started writing our book in 2020, I think a lot changed, right? The tools became a lot more abstract. Your need to know a lot of the underlying gory details that he outlines in the book, I would argue most data engineers at some point should be familiar with it, but that shouldn't you don't need to operate at that level in your day-to-day job typically anymore, right? Like things have just gotten a lot simpler. So that allows you to kind of step back. I would say like, our book is a prequel to his book. I'm currently reviewing the next version of his book, and it's good. It'll come along.
Okay. Yeah. So in your book, you mentioned, at least at the time of writing, there was 91,000 unique definitions of a data engineer. So how do you define a data engineer? And I guess like, how is that different than a software engineer for those that are maybe less intimately familiar with this world?
Yeah. And the number came from the amount of just what is a data engineer? It was I did a unique query search in Google on that, and that came up with 91,000 results, and so that was interesting. But we define a data engineer as somebody who manages the data lifecycle as it pertains to the role as a data engineer, right? While embracing the undercurrents of security, orchestration, data management, architecture, software engineering, and so forth. And the TLDR is definitely a data engineer gets data from somewhere, does something useful to it, then serves it for downstream stakeholders like analysts and machine learning and AI use cases, and maybe reverse ETL and similar use cases. So there's sort of the bridge between software engineers and kind of downstream data use cases, so to speak. So
yeah. So then if you think about software engineering is potentially building, I don't know, an application that's going to be used by some end user in a B2B, B2C sense, the sort of end user, the data engineer is the analyst, the data science, the AI engineer.
Yeah, exactly. And I think that's as it stands today. I mean, there's definitely an argument that these roles will be kind of melding together at some point and perhaps evolving, especially as data use cases traditionally, which are kind of maybe more internal facing, become more external facing and application based. And then at that point, I think there's more of a feedback loop between data and the whatever software engineers are doing, right? And so I think that's sort of the next progression, which we talked about in the last chapter of the book. We call it the quote live data stack, kind of a tongue-in-cheek play on words with the modern data stack. But the notion really is that feedback loops become tighter, streaming becomes a first-class citizen, and then event-based architectures means that there's really no definitive line between applications and quote data use cases. At the end of the day, it's all sort of the same thing. But we'll see if that happens. I think it will. But
do you think that data engineers are not always given as much credit or respect within an organization as maybe other forms of engineering?
I think that's definitely been historically the case for sure. But I would actually extend that to data in general. Data is typically misunderstood. Probably misapplied and underutilized. I think part of that is there's a sense of FOMO around data, where if I'm not doing data, then I'm obviously doing something wrong. So you'll hire a bunch of data people, but have really no idea how to properly utilize them. And so that's whereas the software engineers, for example, right? Like an application is a very I guess the impact of what a software engineer does is very immediate, right? I make a feature and the feature's out there. I make tweaks to the feature and those tweaks are, available for use and so forth. So whereas data is a bit more silent in some ways, right? It's sort of, it's like air. It's everywhere, but you don't see it. But it impacts a lot of things and it powers a lot of things. But I would say a lot of it's just due to the immaturity of the data field. I always like to say that data feels like it's about 5, 10, 15 years behind software. So
yeah, where would you say, so essentially if you have software engineering, maybe that's sort of the most like developed discipline in the engineering space, and then you have data engineering, and then I guess like now you have sort of AI, ML engineering. Mm-hmm. Like where would you put data engineering between those on the like spectrum of maturity?
I think you kind of nailed it really. Like the data engineering is sort of in the middle. ML engineering because it's just newer. I mean that's going to be the least mature. But ultimately, we do have a guidebook, though, right? And a good rubric, and that's just paying attention to what software engineers have already done for a while, and I think borrowing what works and tweaking it for our specific use cases. But it's software's done a lot of great things. They've done a lot of things correctly. I think they've kind of paved the way for other fields. If it's funny because if you look at like there's data ops, there's ML ops, and these are all just borrowing practices from software engineering, and so
yeah, I mean it's like it's a sign of maturity of any discipline where you get more specialization. Like if you look at being a medical doctor from 100 plus years ago, one doctor was delivering a baby, giving I don't know, pulling a splinter and performing surgery. But now you have people who just specialize in what surgery of one specific organ or one specific type, and they're specialists in that thing. And I think we're not quite there in engineering, but there's more and more specialization because the scale of the systems are much more complicated, bigger. It's hard for one person to essentially be able to be an expert in everything and keep all that stuff in their head.
I mean, yeah, software engineering, it definitely has progressed. I think medical analogy is a really interesting one, right? Because you were used to be kind of the general doctor that would go deliver babies in a barn and,
apply the leeches.
Or leeching and bloodletting and all that stuff back in the day. And you realize things mature and there's a lot to borrow. I mean, but when I say so, it feels like the data field's about 5, 10, 15 years behind software. It's not always going to be a linear kind of look back, if you know what I mean. Like there's definitely things to borrow. So hopefully that means that the data field can catch up a lot more quickly, right? Because you already have a good rubric to go off of. I mean, the stuff does work. And like I say, the more that, these fields kind of blend together with the use cases of, data powering more applications and so forth, and AI models becoming more front and center, I think you're going to see a pretty interesting intersection over the next few years that is going to change stuff. But it's already changing workflows too of software engineers. I mean, if you look at what's going on, a lot of people are using Copilot now and things like that to generate code. And that wasn't a thing a few years ago. Now it's kind of the default. So.
Yeah. And I would say the other thing too that helps mature an area as well as bring new talent where they might have gone to more traditional software engineering is how important or hot, what's the hotness of it? And data is really the love language of AI. And of course, there's a lot of stuff going on in the AI world right now. So people are trying to figure out how do I fit into here? How do I I want to go where, to the companies that are at the forefront of technology, work with the best people. So you're going to, I think, see a natural gravitation towards people seeking more of a data role than probably before as well.
Oh, yeah. Yeah. And it's interesting seeing, the role is definitely, the popularity of data has changed. Like I said, when I got into it, it was probably the least cool job you could think of. I mean, at that time, everyone's getting their MBA, right? Everyone wanted to be a quant. Everyone wanted to go to finance. That was going to be the path I was in. I was, still going to be an actuary because that's super exciting too. Joking. But, it got popular, right? Data science became the cool job and everyone became a data scientist. And then they realized that it's kind of hard to do data science without data. So that's what data engineering came into being. And now it's all about AI and so who knows? It'll be pretty interesting.
With respect to data engineering, how important do you think it is sort of understanding the fundamentals of computer science, like algorithms, data structures? Is understanding that a DAG is used for querying, planning, and optimization, or maybe a B tree for some forms of indexing? Does that matter to a data engineer's day to day?
I think it does. I wouldn't say that you, as a data engineer, a good junior data engineer, needs to know all that. I would say what we covered in the book is probably what I would say you should, from a beginner to intermediate level data engineer. But yeah, I mean, as you become more senior, I would expect that you're going to know a lot of this stuff. How would you read an explain plan in a database, for example, right, for a query if you don't understand, various things like B trees and so forth, right, that an explain plan will give you. And so I think in various indexing methods and so forth. So I think the prerequisites, definitely algorithmic complexity and O notation and that kind of stuff is super necessary. Especially as you're starting to custom build. I think early on when you're starting out, if you're just using a data ingestion tool like a Fivetran or an Aerobyte or Estuary or Portable or something like that, and just moving data to a Snowflake, probably don't need to know a ton of stuff, right? You would want to know how to write performant queries and hopefully understand ingestion patterns. But you can get, a lot of the tooling is abstracted away. A lot of that stuff, this kind of goes back to the whole notion of our book versus, say, Martin Kleban's book, which is more about the internals of how all this stuff works, right? But I think at some point, for you to graduate towards being not very competent professionally. Obviously, you need to start knowing this stuff. And having a computer science background, I would say, gives you a huge advantage over this stuff because you already learned this stuff. But I mean, you'll have to learn it one way or the other. But there's great resources out there. You know, Database Internals is a terrific book that I think everyone should read. It's a bit dense, but you know, that's kind of what you got to do. So,
yeah, you know, you mentioned this earlier as well, but essentially, you know, the tooling's gotten much better. Things are easier in many ways. So, you know, where are sort of the hard problems in data engineering today?
I think the hard, you know, thinking a lot about this, I actually don't think that there's much of a tooling gap at this point for solving classical data problems. And by that, I mean classical analytical problems where data warehouse or data lakehouse is needed, right? What I do think is happening is that there's actually a skills gap and a knowledge gap and a competency gap between the people using the tools and the potential that the tools provide. I actually think this is the biggest gap in our industry right now. The data industry is actually not really understanding the fundamental practices, things like data modeling, for example, right? Things like how do databases work? I think because a lot of the tooling abstracts away, you know, a lot of functionality and just, which is great. That's what technology should do. But at the same time, it helps you to understand what's going on under the hood and understand, again, for data modeling, for example, correct ways of how to think about your data, you know, at a conceptual level, for example, and how it relates back to the business or the organization you're in, and then translating that data down to, you know, something that's performant, you know, from a storage and query, you know, at the physical layer of data modeling, right? And knowing all the techniques. If I talk to data professionals these days, actually, a lot of them don't understand or haven't heard of the classical data modeling techniques. If you mention relational modeling to people, they kind of look at you with a blank stare. They may have heard of it once, but couldn't really explain it. And you know, but I mean, and understanding why it's important to use relational modeling and when you'd want to use it, I think is you know, and not just data people. I would say software engineers too. You know, I think a lot of practices are just kind of thrown by the wayside or forgotten about, and this is. But then, you know, consultancies like mine or companies like mine have to, you know, when we come into situations, we're certainly glad that there's a lack of knowledge and best practices.
Because you wouldn't have a business otherwise.
I mean, you know, at the end of the day, consulting is just knowledge arbitrage. It's literally all it is, right? But at the same time, you know, I'm writing books on this kind of stuff, and I feel like that's, you know, and I you know, I'm kind of I won't say moving away from consulting, but definitely, I think my biggest focus right now is just education. I feel like that is single-handedly the biggest gap that we have as an industry. Like I said, there's no shortage of technologies at this point. I mean, new technologies will always come about to solve new problems. That's the nature of technology. But I think there's just a huge gap between what we're capable of doing and where we need to go.
Where do you think that skills gap is coming? Are we moving away from perhaps teaching some of these fundamentals at the university level, or is it people are taking different paths to a career in data where they might be skipping over the fundamentals and be focused more on the tooling? It's kind of like, you know, if you go to a boot camp, 80% of graduates from boot camp are usually focused on front end. They're learning React, but then you might not be learning sort of the fundamentals of actual like computer science and how a programming language works. And you're kind of just focused purely on the technology.
I do agree with his observation 100%, right? So if you look at how, you know, data boot camps, for example, right? It's like, okay, so what's the first thing we're going to learn? Probably Python and SQL, right? Because that's widely used tools. I mean, the whole intent is to get somebody a job, right? So you can check the boxes on a resume, say, okay, this person gets Python and SQL and so forth. But if I were to ask you, okay, so given this this setup, you know, let's say a company, for example, right? And this is what the company looks like. This is what they do. How would you think about their data needs, right? Like what are we trying to do in the first place? I think giving people the ability to see and observe a situation is lacking in the techniques to assess that. And then obviously, as you point out with computer science, understanding big O notation, for example, right? Like, am I going to write like 3 for loops nested together? Is that a good idea? You know, or did I just create like, you know, cubic complexity in my, you know, what I just did there, you know, but if all you know are for loops, for example, and you don't understand the impact of nesting these things, you know, like I see this all the time, right? Or the difference between stateless and stateful programming, right? So again, you know, if you're using a distributed system, you want to write stateless code, right? And you don't want to write things that are stateful for very obvious reasons. But this isn't really taught as far as I can tell. So I see a lot of things. And so I think there's a few reasons for this, right? Obviously, it's people come into it from different angles and are trying to, I think as quickly as possible, get the skills that they need to check the boxes on a job description so they can get a job. And they can't blame them. That was what you probably want to do if you want to get a job. And it just takes a lot of time to master the fundamentals, and it's just not one of the things I think people are incentivized to do, especially at their jobs. It's like, and I'm going to blame a couple of things. I'm going to blame maybe the cult of agile for people that are working at jobs, because the cult of agile, agile, the manifesto started out as being basically a manifesto that describes how we would continuously deliver software, right? What this also in an iterative fashion, but what this also means is that people took that and started thinking that, okay, 2-week sprints is the same as being agile. But it's really hard to I think, to sit down and master the fundamentals and really think if you're only operating in 2-week sprints, for example, right? And I think this is one of the dichotomies in data, is that we're trying to apply a software engineering framework to data, which is fundamentally different in a lot of ways, right? With data, you're trying to compile data, in large case to get context of the entire enterprise. This is not the same thing as delivering features as you would in software engineering. But now we have to, data is very much a thinking person's sport, as I say in a lot of my talks. And this is a fundamentally different thinking exercise and plowing away at 2-week sprints. And so I think that's also part of it, where you just don't have the time to sit back and really assess, what are we trying to do from first principles, and like, what should I learn from a best practices standpoint. And so, I'm sure I could blame a lot of other things, but I'll blame those for now.
Well, I think when you sort of, blindly potentially apply like a methodology, you might not realize there's also consequences to choosing that path. Like, it's just like, if you think about, certain KPIs, we tend to optimize the metrics that we measure. So if you measure the wrong thing, what does that end up doing? It might actually steer you in the wrong direction. Like, I know during my time at Google, everybody's focused on performance reviews that happen twice a year. So if something is a project that takes longer than 6 months, it's kind of, people are more reluctant to do it, because even if it potentially has more impact and it's the right thing to do, but what do I show on my next performance review? And that impacts the bonus I get to at the end of the year. It impacts my ability to get promoted and all this sort of stuff. So you become sort of hyper-focused on these short-term wins, and that leads to short-sighted, I think, choices when it comes to, building a product.
That's really interesting, Sean. Yeah, you're absolutely right. I think it was Charlie Munger. He's Warren Buffett's business partner. He said it best: if you show me the incentive, I'll show you the outcome. So, what you described, it very much fits that. I mean, you have a performance reviews, that's what you're going to be, if that's what you're measured towards, that's what you're going to improve upon. Simple as that, right? So it definitely does come down to exactly what you described. And so that's for good and for bad, right?
So I want to talk a little bit about, what's kind of going on in the world of data. So starting with like data warehouses, how has that area sort of changed over the past, decade or so? And where do you see it going?
I mean, I think the biggest shift is really the movement to the cloud and the modern data stack. So if you go back 10 years ago, or even further than that, I would say 15 for argument's sake, right? I mean, your options at the time, if you're a company and you want data warehousing capability, you could obviously roll your own in a relational database, and they'll get you some way of the way there. It's fine. A data warehouse is meant to be an architectural paradigm. It's not meant to be a specific technology, as Bill Inman would point out. But with respect to the data warehousing technologies, I think what's changed is the modern data stack. I think really democratized the use of data warehousing, right? And by that I mean, November of 2012 is when I sort of put at least in my opinion, is when the modern data stack started. And that was with the release of AWS Redshift, right? So before, you'd have to get these expensive, contracts for data warehouses, usually on-prem. If you're getting Teradata, for example, you might be charged by the amount of cores that you're using, and that can be very expensive. There's a lot of onerous details in that. And Redshift came out, and they're like, fine, it's 25 cents per hour for a core, right? Digital processing unit, I think, or data processing unit at the time, DPU. That was pretty cool. Right. So for pretty cheap. You get a data warehouse and it runs in the cloud, and that's pretty cool. And that ushered in a lot of new technologies, right? Cloud-based data ingestion tools. ELT became a thing for better or for worse. Snowflake, I think they started working on that around 2012 as well. And so, you kind of couple this with the rise of data science too, and you started seeing, I think, at the beginning of the 2010s, the data science and data warehousing workloads are quite different. And I think there was actually a lot of animosity between the data warehousing crowd and the data science crowds, where data science was sort of this hot new thing, and data warehousing was, this old stodgy kind of blue shirt and khakis type of thing. And and then I remember data scientists were claiming, oh yeah, data warehousing is going to die, SQL is going to die. I've heard these pronouncements countless times, right? But that was for years. People were saying this kind of stuff, we're just going to all be writing in notebooks at some point, right? And so, I think Spark blew the lid off of a lot of things too when that came out, right? Because for the longest time you had to write MapReduce in Hadoop, and that's painful for everybody. But Spark, I think, made it a lot simpler and a lot faster. And so, that's maybe around 2014, I think Spark open source came out. And then what was really interesting is, Databricks, for example, they sort of, they were a data science first company back in the day. And I remember using a lot of their stuff and thought it was pretty awesome. Then you started seeing a convergence though, right? I would say kind of the late 2010s is when you started seeing, Lakehouse come onto the scene. And I forgot to mention data lakes. That was a big thing. So as well, right? But the notion was, we'll just collect all this data and maybe we'll use it later, right? But I think what happened was, do you ever watch those hoarder shows on cable?
I know what you're talking about. Yeah.
Yeah, they're pretty awesome. I love watching these shows for some reason. I'm a pretty sick person. But that's what a lot of companies' data systems ended up looking like.
Yeah, we don't know what we're going to do with this, but we know there's some value in there somewhere, so we're going to hold on to it.
Right. Yeah, it's like it's like having value in some smelly pizza box that's 5 years old that you just want to keep around for some reason. And so that happened. I think people quickly realized with the data lake that maybe probably other ways to do this, right? Because curating data sets and discovering data sets. I mean, it becomes almost impossible at some point, just because it's how the hell do you find anything? You can't, right? And so then GDPR comes along in 2018, and now you have to be able to find your data, and if you want to delete it, for example, because you can get fined pretty heavily if you can't. So I think that's when people started taking at least governance a bit more seriously. Because before that, it's it was a free for all. This. I mean, it's.
Well, even now, there's a ton of companies that are just sitting on a mountain of data, unstructured data that's encrypted in a bucket somewhere. And they're like, we can't touch it because it's got, PII or PHI or, something in it. And, but someday we'll be able to do something with this.
Someday. Yeah. So it's interesting. And then that's what's changed, I think, is you just saw the combination and sort of the convergence of data science and traditional data warehousing analytical workloads to the point now where these systems are very much converging. I mean, you haven't, there's Data Fabric in Azure, there's Databricks, Snowflake, are basically on track to be the same product, in my opinion, feature for feature at least.
Yeah, I mean, they basically want to own all the data at this point.
Yeah, BigQuery's dope, and Redshift is I think catching up. So yeah, I mean, it's so the Lakehouse paradigm is sort of where everything is going towards, right? And that was a big evolution.
Yeah, do you think the data lake, as historically we know it, is just going to go away?
I think so. I don't see much of a need for it. I mean, because you can get the best of both worlds of the lake house, and you combine your structured or semi-structured, data sets, along with your unstructured data. I mean, that's with a management and a governance layer on top of that. I think that's a key distinction, because otherwise you would literally just have a data lake as we called it in the past. And nothing wrong with data lakes. I just think that the world's kind of outgrown that chaos that it provides. I mean, you'd have to be a very disciplined individual to do a data lake. But I mean, or disciplined organization. I mean, it certainly is done. A lot of companies have done it successfully, but I don't think it's everyone's cup of tea.
So this convergence is going on. Do you think that this, we now also have the emergence of all these, vector database companies. Do you see that also moving into essentially a single platform?
Yeah, I think inevitably it will. Yeah. I mean, you're starting to see this. kind of workload already, right? So
Yeah, I mean, I think like MongoDB now is supporting vectors, for example.
yeah, it makes a lot of sense. And so, yeah, I think that you're going to just see a convergence of all this stuff, especially with the rise of unstructured data sets, because it's like, I think for the longest time, there are definitely people, definitely companies with a ton of great use case for unstructured data, but it was sort of this tale of two worlds, right? You had the structured data people over here and the unstructured over here, and these worlds didn't really, talk. But now, with the rise of, generative AI everywhere, right? I mean, these worlds will collide. They have to, but it's going to pose some very interesting dilemmas. But I mean, because you can use generative AI with text, images, all the above in a multimodal setting, then it's like, why the hell not? So you're absolutely right. Vector databases will, I think, become first-class citizens in pretty much every infrastructure. Because you're going to need that similarity search capability, right? It's just
it's a way to essentially take action on the unstructured data. Do you think now that we have more technologies that allow us to actually leverage structured data, that's changing in any way the type of work that data engineers are doing and are responsible for?
It's a good question, and it's something that I was thinking about last week quite heavily. I did a podcast episode on this, and I think it was titled "Things I Didn't Expect to See" or something like that. I don't know. I never remember what I record, but it was So I was at Matillion's demo last week. I was at their event hosting it with Mark Buccanetti, and we had a bunch of AI announcements, right? It's like every company's announcing some sort of AI feature. What I thought was really interesting with this is, okay, so they're letting you do prompts now to create data pipelines, right? I thought that was interesting. I'm still on the fence of whether that's good or not, because if you're dealing with a stochastic system where if I give you a prompt, I don't know what the output's actually going to be 100% of the time.
Yeah, reproducibility is a problem.
Yeah, it's like, so am I going to do like prompt reviews with my team now? What would that look like if I were in a CI/CD pipeline, for example, right? So I think that's an interesting one, but hey, it's happening.
Yeah, I mean, ideally, like when I think about something like CI/CD or I don't know, orchestration or something like that, like reliability and reproducibility are really important, and those are two areas where it is not necessarily the core value of Gen AI right now.
No, it's exactly the opposite. It's just like, so how are you going to unit test these things, for example, right? I have a promp.
I don't think anybody knows the answer.
Creating a pipeline, right? It's exactly the whole. Yeah, it's like so. Is this a good idea to do? I don't know, but we're doing it anyway. So then the other thing they demoed, which I thought was pretty cool, was the ability to use large language models, to comb through a bunch of text data, right, in your data pipeline. I think that was pretty cool in the way that it's just like super easy to do, right? Because this is traditionally a tool that was more for structured data sets and just querying databases, but now I can come up with sentiment analysis or some sort of analysis on my say customer review text data, and so I think these worlds will collide, and it can do the same thing with images and stuff. So I think it's going to unlock a lot of capabilities that so far probably data engineers weren't even thinking of, right? Because it's like the workflow is typically, okay, so I'll just get data, put it somewhere, serve it for downstream use cases, but those downstream use cases they're growing, right? So I think that's pretty exciting, and it'll change the workflow of data engineers for sure. Vector databases, again, that's another big one, right? So, I think for data engineers now, you're going to be intersecting the worlds of ML engineering and ML ops in ways that probably you, at least this time last year, probably weren't even thinking about.
Yeah. This time last year, most people didn't know what a vector was, so.
No. I mean, the hype back in through 2021 to now was the feature stores, right? You don't hear much about those right now.
Yeah, because you don't need features, and Gen AI will find the features for you, I guess.
Sure.
So you were talking a little bit about sort of the MapReduce Hadoop era, and I think it's kind of hard for people maybe entering the world of data systems now to really like understand the impact that those systems had on large scale data problems back in the day. But a lot of those modeling approaches, even things like I don't know, using one large table in order to overcome limitations of the technology, we had at disposal at a given time, like eventually those things got simpler and like the underlying framework was taken care of in terms of the complexity. So I guess like looking at today, like what sort of hacks or workarounds are we doing today that you think will go away and eventually just be something that kind of magically happens behind the scenes for us because we have a proper abstraction layer?
Good question. I've been thinking about this a lot from the context of generative AI, actually, and what it can do for data modeling. I think the hacks we have right now, and I talk about data modeling a lot because that's what I'm writing a book on. That's pretty much the only thing on my mind at this point. But it has huge impacts, right? Hacky data models mean that you can spend more time than you need to on getting really bad answers, for one. So double whammy, right? What do I mean by this? Well, if you have an inefficiently created data set, say a giant wide table, right? The impacts can be quite severe. For example, you might have lots of duplicates, you might have lots of redundancies, you probably don't even know what the hell's in there, right? Query patterns are chained together, right? So if you're using, certain transformation tools, and you don't understand modeling practices well, you're going to basically create probably just a bunch of tables or one big table or some weird thing in between or just a bunch of queries. I think those are the hacks right now. It's like we're super reactive, trying to answer various questions. And what that means is you have just an enormous amount of sprawl, right? So if you thought the data lake was bad, I would challenge people to think that, or to at least observe the workings of their own data practices, for example, and ask, okay, so how many queries do I have that are just sitting out there right now? How consistent are they in arriving to some sort of base level of truth in the questions I'm being asked, right? Can I consistently answer questions from the data sets I have? Often, probably not, right? You have very much divergence of truth. So I think a couple of things I've been thinking of is, okay, so generative AI could certainly help this in some ways. I think especially when coupled with knowledge graphs. I think you're going to see the rise of graphs to provide more context in terms of data that people have, and generative AI I think will just be I think obviously the being able to search through data sets is great, and they'll get better. But I think also there's a capability of it actually being able to go back and reformat data sets into a better form, right? I've been experimenting with this myself, and I think there's actually quite a bit of promise in this. But yeah, it's still super early days. We'll see. But those are the hacks I see right now. It's just, I think, again, back to the nature of the type of work that people do. You're reacting to questions and needs of the business and constantly firefighting. And this doesn't, but it's ironic because we're supposed to be, data professionals and knowledge workers and stuff, but we're constantly just always in firefighting mode. Do
you see that's because there's, due to like a lack of resourcing traditionally in the space, so you don't have time to sort of take a step back and do the proper planning. You're more just like you're taking orders at a restaurant essentially and reacting to those in the moment.
Oh yeah, I think that's a very good analogy, Sean. Yeah, absolutely correct. Yeah, you're understaffed, under resourced, especially now. Data teams have been kind of cut to the bone, especially like along with other teams. And it's like you're going to do what you can to get by in the day, and that's about it. Or you do what you can to get by in the sprint.
Yeah, I feel like all like sort of non like directly revenue generating teams have been suffered over the last year in terms of where the cuts are making.
Yeah. I mean, that's the reality of business, right? That's going to happen. And that's just, so if you're on those teams that are still around, then yeah, you're going to be expected to do a lot more with a lot less. And that's just how it is. And so, yeah, you're not going to have time. You're just going to do what you can to get your job done, right? Because again, it's about hitting whatever KPI you're supposed to hit, whether that's real or imagined, right? And so most companies don't have KPIs. That's the crazy thing. Or most teams I've seen don't even have a sense of a KPI. So you're just trying to strive towards whatever you think is the right thing to do, or whatever you think your boss thinks is the right thing to do. So, because it's all about self-preservation. So of course you're gonna, and restaurants are a good example. I mean, I've worked in restaurants before. Maybe you have as well. It's a very stressful environment, right? It's like I can't think of a more of a pressure cooker than a place like that. But that's a lot of teams these days too. So you're absolutely right.
Yeah. One of the things you mentioned there was, this challenge around data duplication. We were talking about the lake and the challenges with the data lake is, it just becomes a management nightmare because you have all this data just kind of sitting there. You have to be very disciplined about actually, cataloging it to be able to do anything with it. But I think even in the structured world, one of the major problems that companies have is just duplication of data, especially when we're talking about PII, and that leads to this huge sprawl problem. And you create the same problems where you don't know, what you're storing, where it's storing. And in the world of GDPR, as well as other, 100 plus regulations that exist in the world, it becomes very, very difficult to be compliant as well as secure the data. So I guess, what are your thoughts on that? Do you see this as a big sort of challenge for companies that you work with as well?
Huge problem, right? And especially with the popularity of SaaS applications, right? Because now you have the ability to have no control of your data model, and then you have every ability to duplicate data to your heart's content, and all kinds of systems that don't talk to each other typically, right? So the temptation's there. In a lot of cases, data duplication occurs, or triplication or quadruplication, whatever. How many replications you want to talk about? You can do this to your heart's content in all these different systems. No way of reconciling it. So you might have different versions of a customer or different versions of products. Cool, awesome. So that's what we're in right now, though.
So there's this quote from your book where you said it's easy to get caught up in chasing bleeding edge technology while losing sight of the core purpose of data engineering, designing robust and reliable systems to carry data through the full life cycle and serve it according to the needs of the end users. So there's this ever-changing landscape of tools, some of the things that we touched on in this that data engineers can use and learn. Do you think that we get too fixated in love with tools and these beautifully complex modern data stacks when perhaps something simple could just do the job?
Oh yeah, all the time. You got to consider it from the angle of an engineer too. You get paid to engineer stuff, and you're always trying to find the cool new thing, right? Because you just want to tinker with stuff, right? And I think there's an element of resume-driven development too in this, where constantly looking at what's the hot new technology, what's going to help me get my next job, right? I'm not going to be a COBOL programmer. It's not that cool, even though I could probably make a ton of money doing that. You know what I mean? But it's like that's just always a temptation. It's I think it's just human nature, though. The grass is always greener on the other side. So there's always a new open source technology you should try out. There's always a new vendor with a cool product that they tell you should go try out. And so there's a lot of noise, right? But you gotta spend your time also focusing on what the business needs, and that's important. But and the fundamentals are hard to do too, right? Because again, I always tell people if you master the fundamentals, it makes it a lot easier to assess all these new technologies, because it's like rarely is there anything that's like completely novel and new out there. I would say very, very rarely does that happen. Often what happens is that there are just variations and permutations and some sort of combinatorial stuff on existing ideas and technologies, and that's how things morph. Very rarely do you see something that comes out of left field that's completely new, right? Doesn't really happen in our field.
Yeah. So do you think that a lot of this, I don't know, getting better at sort of making these decisions in terms of technology choices, or knowing when, hey, I don't need to apply this whole stack when I could do this pretty simply with a spreadsheet or something like that, comes from just maturity in the space and experience.
Yeah, I think you got to spend your cycles sort of getting your butt kicked around a bit, and I think that it brings you back to reality. I do a lot of stuff in spreadsheets. Why? Because it's really easy to do, and it costs me nothing, right? And they're super efficient. They're unreasonably effective for a lot of stuff. But I think what you realize is, really it comes down to you as the individual and how effective you are at solving problems. The tools are just there to be tools, right? But I think when you start out, right, you want to compensate with your lack of knowledge and lack of skills with tools. That's a temptation, because it's like, well, I know how to use these tools. I probably don't know what I'm doing, right? And that's the kind of the fresher mentality that I've seen, at least. But that changes. I think ultimately you end up, my favorite tool is really just a pad and paper these days, and drawing out what I think the solution should be. And going on long walks and thinking about the problem. That's my secret weapon. I don't need technologies to do that up front. I certainly need it to help implement things, but then you know what you need to do, right? But that if you're coming out of college, you're not going to have that ability. Why would you? you don't have the experience. You wouldn't know how to solve it from, but that just comes with time and comes with getting a lot of bruises.
Yeah, you got to over-engineer a few systems before you realize maybe you spend a little bit more time planning before executing.
Oh yeah, and I think the big question you need to ask is why? Why are we doing this at all? Like, what is the objective? Like, I think if you can treat things as a journalist and approach it from that perspective, you just ask really good questions. You'll have better context. Sometimes the answer is you don't need to design this. You don't need to build this at all, actually. So that is an answer as well. Not everything has to be built.
Right. Yeah. I mean, you could potentially even pay for service.
Exactly.
Yeah.
Yes. Like I was reading an article on Hacker News a few weeks ago. Somebody had, I think it was at Uber. They wrote their own spreadsheet. Like they created a spreadsheet because like the Excel or whatever didn't do what they needed to do, and so they over-engineered the spreadsheet. And then I think something happened, and it was never really used at all.
Yeah.
Right.
Yeah. I feel like Google had built up a culture of sort of engineering everything. And I think in the early days, it made sense because one of their core assets was engineering, and they were doing things at scale well beyond essentially like a lot of services that existed. But now that's not really the case. But there's still sort of this historic culture around like, hey, we're not going to use Salesforce. We're going to write our own CRM, or we're not going to use HubSpot. We'll use our own marketing automation. But then you have these kind of like internal tools that are subpar to really what the industry standards are in some fashions, because internal tools are never going to get the same resourcing that Google searches or ads.
Yeah, that's exactly it, right? I think last time I checked as a Google Cloud partner, they use Salesforce for the Google Cloud CRM now, right? So it's like, you can't escape the inevitability that there are better tools out there sometimes, and maybe you don't have the best tool. But you're absolutely right. That's a temptation. I mean, I know people who have written their own databases when like MySQL or Postgres would have done just great. They're like, oh, I have to build this. I'm like, I guess if that's what your boss will let you do, I don't know why you would do this, but
yeah. I mean, even as a lot of database companies are, start with Postgres and then use the extensions to, do whatever they need. That's why there's so many like Postgres, sort of core Postgres. I mean, it's kind of like an operating system. Like, let's start with the Unix kernel and then go from there. We don't need to reinvent that piece.
Oh, exactly. And Postgres is awesome. Like, Linux is awesome. I mean, use these, as we say in the book, and we write, I think in chapter 4 about choosing technologies, build versus buy. It's like, you should build when it's a competitive advantage to you, and it's uniquely yours. Like what you mentioned with Google, like they were operating at a scale, solving problems in a way that nobody on earth is doing. Of course, you're going to have to build this on your own. Like, I mean, I don't think it's for lack of trying, off the shelf stuff. And breaking it, right? I mean, they did that, and so this is what they had to do. Like I talked to Jordan Tagani about the work they did with BigQuery, right? Like he was a founding engineer for that, and it's like, yeah, you're building that because it's a system that you need and doesn't exist right now. You have to run analytics on tons of data. It's like that can't really do that. You're gonna have to build it, right? And so that's. But you got up. I think you got to understand like where you are as a company and as a team, right? Like most companies aren't Google, and you don't need to do this. And so, I think there's a temptation for engineers, software, data, or whatever to read like Google's blog, Uber's blog, Netflix's blog, and say, okay, I'm going to go do that at my company, right? And it's like maybe it'll work, but do you have the same problem in that same way? So
yeah. Also, do you have 100 engineers to throw at a problem that's like non-core to whatever it is your business model is?
Right. Exactly.
So, what do you think are the big unsolved problems in data engineering?
Yeah, it's a good question. I think it's really about integrating data into, like I said, more application workflows, and that whole feedback loop, I think, is like one of the big sort of unsolved problems. I would say again, like the capability of solving like the classical data problems. I'm talking about analytics, for example. I think that we have the technology to do that right now. We've had it for a long time. So I think it's a combination of skills and practices. I think that's one of the big problems for data engineering is just, I think leveling up on the concepts, I think to be most effective at your job. But we already touched on that. I think there's a lot of reasons for this. And then, but the big unsolved problem I would say is, just that feedback loop between just in the data lifecycle and bringing it full circle like that. And I think we're going to continue solving I'll throw out a trigger word for the audience, and people will have an aversion to this or like it. But data mesh, I think, has a capability of helping solve this problem. But we're not there yet.
Have you seen anybody actually implement some version of data mesh?
I've talked to people who have said that they've implemented some version of it, right? And so, but if you were to talk to people like Jim Dagani, who's a really good friend of mine, I mean, I think that she maybe has a different opinion of that, right? So I think it's sort of in the eye of the beholder. But I think the notion of data sharing in a decentralized way like that, I think, has been done to some degree. But I think according to her perspective, maybe there's some work to do on it. But we'll get there. I hope so. But what it means, though, and that one of the conclusions that she draws on, which I don't think gets discussed a lot, is that actually changes the shape of the roles people have, right? So if you're a data product developer, as she calls it, you're bringing together software engineering and data practices all into one, right? So the notion of a data engineer, software engineer, ML engineer, this all kind of goes away, and it's just now you're delivering data products. And I think that is a kind of the fundamental shift, which if you were to take what she proposes to a logical conclusion is exactly what would happen. So whether we get there or not, I don't know. But that's a debate for another podcast. So.
Yeah, that's a whole topic itself. So as we start to wrap up, is there anything else you'd like to share? And how can people sort of reach out to you, get in contact with you?
Yeah, LinkedIn's good. Just send me a message. I usually respond. If you send me a sales pitch, I will not respond. So you'll actually be moved to the other box where that's purgatory for messages. LinkedIn's good. I'm taking a break from speaking. I think that we're recording this in kind of late November. But I taking a break from international travel for several months. I'm working on got to finish my book, so that's coming out first half of next year. Then got a course I'm working on with deep learning AI on data engineering, so that's gonna be pretty dope. Really looking forward to that. So that specialization is so you can keep an eye out for that too. Can't commit to a date on when that'll be out, but really, my head's down on those two projects right now, as well as starting a new company. So starting a content and publishing company that will be announced early next year. And, got a lot going on.
Yeah, it sounds like a lot.
Yeah. So,
awesome.
Yeah. And CrossFit, we forgot to talk about that. So gonna get back into shape doing that stuff. I think we actually have a mutual friend. So we were talking about on the show. So she's gonna be doing some programming for me. That's Colleen Foch. So if she's listening, shout out. So
yeah, Colleen's amazing athlete, far superior. I can't comment on. I don't know what your athletic ability is, Joe, but I'm gonna just warrant to guess that Colleen's is above yours and certainly above mine.
Oh, it is. It is. Yeah. Even though she's quote retired from CrossFit, she still will completely mutilate anybody she competes with. So yeah, just but it's cool. I think hanging out with people like that because I like to unplug from the data stuff as well. It's fun, but it's nice to hang out and do other stuff. But she's a data person too, so it's kind of funny. So anyway, but yeah. Do you CrossFit much?
5 times a week.
Jesus. Okay, it's a lot.
Yeah, that's how I reset my brain. A little bit
of...
You're
tired?
It's a way, if you do something physically hard, there's no way I can be, sort of thinking too deeply about, work and other things, which I spend most of my time kind of thinking about, so.
Oh, man. Yeah, just go do Fran every day or something.
Yeah, exactly. There you go.
It's gross.
Well, thanks, Joe, so much for coming. For those listening, I highly recommend The Fundamentals of Data Engineering. A fantastic book, and hopefully, once some of these other projects land, if you want to come back and chat about them, I'm happy to have you back down there.
Yeah, I'd love to. Or we can do it in person. We can do a CrossFit workout and do a podcast.
Yeah, there we go. All out of breath and sweaty.
Probably before, because we'll be very winded after. Yeah. Awesome.
Thank you so much. Cheers.
Yeah, thanks, dude. All right, take care.